Hello class, this is Mr. Gibson and I am going to go over the two sections that we were supposed to cover tonight, which is 310 and 311 as according to the syllabus. But there's one other thing I would like to address, and this was brought to my attention today about the exam 3. As you all see, exam 3 is listed here during the week of March 15th through March 18th. Now, exam 3 will open tomorrow. But as you can see here, we're not going to cover section 3.12 until next Monday. So what I have done, I have this opened up, this exam is opened up until the 28th. So you still will have a lot of time to complete the exam even without the one section. Because again, the exam is not due until March 28th, even though it is open tomorrow. So as you see here, as far as what we're supposed to do with 3.10, we're supposed to do problems 1 through 7 odd, and then 3.11, we're supposed to do problems 1 through 9 odd. Now, just like I did before, I'm not going to do every single problem, but I may end up doing the majority of them to get you all an understanding of this section. Now, of course, you can contact me at any time to ask any questions, but I will be trying to use this format in order to assist those of you that are not able to make it to class as far as the live sessions, or those of you that do make it to the live sessions but maybe need a refresher. So this will be available to you, and I will send you out the link later today. Okay, now let's put away this syllabus. Then we're going to go to page 357 for 310. Okay, now it says, according to IDC, the International Data Corporation, the global shipment of smartphones has risen and will continue to rise at least through 2021. The following data shows global smartphone shipments and their forecast from 2012 to 2021. Okay, A. It says use your graphing calculator to create a scatter plot of the data using T, the number of years since 2011, as the input value, and G of T, the global smartphone shipments measured in millions of units, as the output value. Okay, so basically what it's saying here is T actually is our X value and G of T is really our Y value. So it's telling us here that X would be the years since 2011 and then Y would be the global smartphone shipment in millions of units. Okay, so now we're going to put this in the Desmos calculator. Let me pull up the Desmos calculator really quick here. Well, I'm going to try and be quick, I should say. All right, let me move this over here because we kind of need all of this space. All right. Okay, so now the first thing we should do is add a table. Now, the reason why I'm telling you to use X and Y is because, as you see here, this is already set up in X and Y. At the end of the problem, we can add in our T and G of T. So now we're going to type in these values. Now remember, this is since 2011. So our first value would be 1, and 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, these are our values since 2011. Now we're going to type in the millions of units. We have 725.3, 1018.7, 1301.7, 1437.2, 1470.6, 1517.0, 1585.5, 1642.3, 1697.0, and finally 1744.6. Okay, now I'm going to expand this out so you can see what the graph looks like. Looks as though, yes, I'm going to have to change our Y values. So let me go back here, hit the wrench here, and we'll go down here to our Y values. You notice your Y values, the lowest is a little over 700 and the highest is a little under 1800. So what we could do with our Y axis, we can make this 700 and we could go up to, let's do 1800. Okay, now by doing 700 to 800, as you see here, we can see the graph a little better. But we might be able to do it just a little better than this here. Let's see if we can, instead of, let's see, with the X values, well, that's just 1 through 10. So let's do that. Let's change this from 0 to about 20 for the X-axis. So we got 0 to 20 for the X-axis, and then we also have these values for Y. Now our graph looks a little better. Now we can see a good little shape for the graph. Okay, now that we took care of that, let me just expand this out so you can see what it really looks like. So as you see here, this is the expanded version of our graph. Okay, now we look here at B. Does the scatter plot indicate that the data may be logarithmic? Now, the answer is yes, because we look here at B, the data, according to the graph from the graph I showed you on Desmos, that it could be very well logarithmic. The data tends to increase more slowly as the input increases. Okay, now we look here at C. It says determine the natural log regression equation. But before we do that, let's take a look back at the graph. So I want to make sure that you all understand the graph here. Okay, when I put down that the data, let me pull this back here. When I put down that the data could be very well logarithmic, the data tends to increase more slowly as the input increases. Now remember, the input is your X values. And then when they talk about the data, it ends up being your Y value, which is basically showing the final answer for the data. If you notice here, as you go up, it's going up slower. Because as you see, this is going from 1 to 2. Okay, this went up almost 300. 2 to 3 went up almost 300. But 3 to 4, it went up less. It went up a little over 100. 4 to 5, it didn't even go up 100. 5 to 6, it didn't go up 100. And as you see, this is growing very, very slowly. So that's what that statement means. Now we move on here to C. It says determine the natural log regression equation. Round your values to 2 decimal places. Record the regression equation below and add the curve to your scatter plot in part A. All right, so this is what we would need to do. Okay, now what we need first in order to solve this, we need to know what the natural log equation is. The general natural log regression equation is y is equal to a plus b times the natural log of x. Now this is what we would need to do. We would need to put this in our Desmos calculator. Now I'm going to write out how you should type this in your Desmos calculator. It should be y sub 1, the tilde symbol, a plus b, and then you could hit the natural log of x sub 1. Now this is what we're going to type down here. Oh, and one other thing. You have to check the log mode button. Have to check log mode. Okay, so let's go through it. You have y1, then we hit on the keypad, then we will go to our ABC and hit the tilde, and then we will have a plus b. Then we need to hit the 1, 2, 3 to go back here and click on functions. You go to miscellaneous, hit natural log, then x1, and close out your parenthesis. Now as you see here, the line is drawn. This is the line of best fit. We have to click the log mode, and then now we can write our equation. Now remember, the initial problem asks us to write this as using g of t and t. Now remember, g of t, matter of fact, I'm going to write this out first as this equation. It'd be y equals 757.43 plus our b is 434.68 times the natural log of x. Okay, this is rewriting it as this here. But remember, we must put it in g of t and t form. G of t represents your y. So it'd be g of t equals 757.43 plus 434.68 natural log, and then t represents your x. So this is the form they will want you to write this in. Okay, now we move on. We move on to D. It says, does this appear to be a good fit? Explain. Okay, let's take a look back at this graph. It does look like it's a good fit. We could say based upon just looking at the graph, but we had a correlation coefficient, or we could say our R squared value is close to +1. So we could just say R, or we could do the R or R squared. It doesn't matter. Well, let's just say we do R is equal to 0.99, which is, actually this is supposed to be D. R equals 0.99, which is very close to 1. So it is a good fit. Now we come down here to E. Now E says, use your model to predict the number of smartphones that will ship globally in the year 2025. Now, when they say use our model, they're talking about the equation we came up with. This G of t is equal to 757.43 plus 434.68 natural log of t. Okay, so now for t, we're going to substitute in. Now remember, it says 2025. Now remember, our initial problem said everything was from since 2011. If we go back up here to A, it says since 2011. So 2025 from 2011 is actually 14. So that means here that our t is equal to 14. So we would substitute in 14 for t. So we had g of 14 is equal to 757.43 plus 434.68 times the natural log of 14. Now we could put this in our calculator. Or, well, there's a couple things we could do. We could click on the graph here and then move this value here until we get to 14. And that would give us the value 14. If we round to one decimal place, it should give us 1904.6 for 14. But since we have our equation, we could substitute it in. We could type it in here. You could do 757.43 plus 434.68. Then we need to get the natural log of 14. And as you see, we have the same value. So our final answer would be 14, 1904.6. And we know that that is considered to be millions as far as the shipment of smartphones. So that would be our final answer. So we write out our statement. The model predicts that in 2025, there will be 1904.6 million smartphones shipped globally. All right, now that took care of problem number 1. Now again, we're supposed to do 1 through 7 odd. So I think I may just pick one more problem. Let me see. I think I might want to pick problem number 7. Yeah, I think 3 and 5 you can handle. So we're going to go to problem number 7. See if I can move this along here. I think problem number 7 is on page 360. All right, problem number 7. It says the following formula can be used to determine the time t it takes an investment to double or triple, and so forth in value. Okay, we have this formula here where m represents the number of times the investment is to grow in value. M equals 2 is double, m equals 3 is triple, etc. R is the annual interest rate expressed as a decimal. N is the number of corresponding compounding periods per year. So A, how many years would it take an investment to double if you are receiving an annual rate of 5.5% compounded quarterly, where N equals 4? Now this gives us a lot of valuable information. Okay, first of all, let me get another sheet of paper here. First of all, let me write down the equation. This is number 7. T is equal to the natural log of m all over n. I made that look like an H. So it'd be n times, all right, natural log of m over n times the natural log, parenthesis, 1 plus r over n. All right, now let's take this piece by piece. They tell us here M represents the number of times the investment is to grow in value. It tells us here they want it to double. When it double is M equals 2. Okay, so far we know our M is 2. That's the first thing. Now it tells us in this problem that our annual rate is 5.5%, which when we turn to a decimal is 0.055. So we have our R. And then finally our N. Our N is given to us. It says N is equal to 4. So now we have all the elements we need in order to solve this problem. So we have T is equal to the natural log of 2, because that replaces M. Then N here would be 4 times the natural log of 1 plus the rate is 0.055 and the N is 4. So now we could just put this right here in our calculator. Pull up the Desmos. And we could type that in. We had a natural log of, what was that, 2. Then we could hit the division sign. So that would be our numerator. Our denominator would be 4. Then natural log. In parentheses, we have 1 plus 0.055 divided by 4. Press this arrow here. Close off that parenthesis. And we have our answer here. Now, I don't recall reading anywhere where it tells us to round to a certain decimal place. So let's round to 3 decimal places. So if we do 3 decimal places, this will give us 12.689, and that'll be years. So at 5.5% interest, it'll take 12.689 years for the money to double. All right. Now we go to B. B says, how many years will it take the investment in Part A to triple in value? So basically, since this was Part A, Part B is basically exactly the same except for this would become 3. Everything else is the same. Only thing changed was your M. So it'd be the natural log of 3 all over 4 times the natural log of 1 plus 0.055 divided by 4. Now with Desmos, this is nice and easy. All you got to do in Desmos is go up here, backspace, put in the number 3, and it gives you your value. So this would be approximately, if we round to 3 decimal places like we did the previous problem, it'll be 20.112 years. All right, now we're going to move on to C. It says, suppose the interest on the investment in Part A was compounded monthly, N equals 12. How long will it take the value to double? Okay, so what they're saying here is the only thing they're changing is your N value. So you will go back to A, and the only thing that you would need to change is your N value, which would be this 4 here would become a 12. Actually, yeah, this N will become 4, will become a 12. But then, wait a minute, it's compounded monthly. All right, yes, and then this 4 also will become a 12 because both of these originally were N's. So we'll go back up here. It'll still be the natural log of 2 all over 12 natural log 1 plus 0.055 all over 12. Now again, what's nice about Desmos, you go right here to Desmos, and all you have to do, well, first you got to change this 3 back to a 2, and then this 4 will be 12, and this 4 will be 12. And then it gives you your answer here, round to 3 decimal places. It'll be 12.632 years. And that's basically it for section 310. And then you will have the other two problems that you need to complete. Okay, now, let me pull back up the syllabus. Okay, now we're going to look at 311. 311 starts on page 367. And it goes to 369. And we only have problems 1 through 9 to complete. All right. So let me see here. All right, now it says number 1, use the properties of logarithms to write the following as a sum or difference of 2 or more logarithms. Okay, now I'm not going to go all the way back through this to find the different laws. I will talk to you about them as we come to them. But just to let you know, if you flip back, starting on page, what's that, 362. I'm going to go back to 362 just to show you the example here. On page 362, if you look here at this box here, this blue box, it says property of the logarithm of a product. And it shows you what will happen if you have log base b of a times b. And you can see here it becomes addition with both of them having a log with the same base. And then it also works in the reverse. You have log with the same base and they're added. You can combine it to 1 with the log the same base and multiply these two values. And then I guess I need to run through this. Let's see, do we have a division? Yeah. Okay, the property of the quotient, because remember the opposite of multiplication is division. So since we know the opposite of multiplication is division, we know if we multiply with the same base with the log and we do addition, then that means that if we divide with the same base, we would do subtraction, which we have here. And we notice that it works both ways. So now we're going to go back to number 1 on page 367. So they want us to write this using the properties of logs. All right, so we have 1a. So we have log base b of 3 times 7. So they want us to separate this. So it'd be log base b of 3 plus log base b of 7. Now, if you want to, if you're having trouble writing the bases where they're lower, you can put these values in the parentheses to let it be known that that's not part of the base, but you don't have to. Okay, now for b. B, we have log base 3 of 3 times 13. It's the same process, except for instead of b, we would have 3 here. Log base 3 of 3 plus log base 3 of 13. Now, this requires one extra step, because if you notice, the base and this value here are the same. And we learned this in the previous, I think it was 3.9, where if we have the base and this value is the same, they would simplify out to 1. So this actually becomes 1 plus log base 3 of 13. So that will be your final answer. Okay, now we come here to C. C, we have log base 7 of 13 over 17. So we have log base 7 of 13 minus log base 7 of 17. And that will be your final answer. Now we come to D. We have log base 3 of xy over 3. Now we got to be a little careful here because we have a division and multiplication. So what I would suggest is let's start with the numerator, which is x times y. So what would end up happening here is this will end up being log base 3 of x plus log base 3 of y. That would take care of your numerator. Now your denominator is a 3 here, right? So it'll be minus log base 3 of 3. Now the problem is, like we did in the last, in B, log base 3 of 3 gives us 1. So this will become log base 3 of x plus log base 3 of y minus 1. And that will be your final answer. Okay, now that took care of problem number 1. Now since we're supposed to do 1 through 9 odd, that's only 5 problems. So I'm going to do 3 of the 5. So let me pick up the next one. I know 3 you could try on your own. Let's see, number 5. Yeah, I think number 5 you can handle on your own too with your calculator. So I'll do problems 7 and 9. So let me move on to problems 7 and 9. Okay, here's problem 7. Okay, it's at the bottom of page 368. It says, write each of the following as a logarithm of a single expression with coefficient 1. So basically what they want you to do, they want you to combine all this into one logarithm. Now this is the opposite of what we did from problem number 1. So for 7a, we have 2 times log base 2 of 7 plus log base 2 of 5. Now, I want to go back and show you this. It's on page, actually it's on page 364. We go back to page 364. Down here in this blue box is the property of a logarithm of a power. If you have log base b of a to the p power, that is the same as p times log base b of a. And then it works in the reverse as well. So taking this knowledge, back to page 368 for 7a, you notice we have 2 times this log here. As a matter of fact, let me have this. Let me go back to 364 so we can have the formula as I go through the problem. Okay, as you see here, this, and I'm just talking about the first part, not the second part. This right here looks very similar to this here. You have 2 would be your P. You got your log. 2 is your base, and then A is your 7. Now, what this is saying is you could rewrite this as this here. So let's do that. So we have log base 2 of 7 to the second power. This number becomes the exponent, as we saw here on page 364. This P became the exponent here. So then this would be plus log base 2 of 5. So this would be log base 2 of 49 plus log base 2 of 5. So now we combine these here. So this would be log base 2 of 49 times 5. Now, just to see if I could get back here to the formula. It's the previous page. Okay, here's the formula. Now remember, we're going backwards. We're going from here. It won't let me highlight it for some reason. We're going from here back here. So when we get here, this log 2 49 plus log base 2 of 5 is the same as this here. And if you notice, the log and the base stayed the same. And then we multiplied the A and B, which is 49 and 5 here. Okay, so now 49 times 5 will give us, what's that, 245? So it'd be log base 2 of 245. And that will be your final answer. Now, if you're a little confused, that's understandable. But we do have some more practice we could do. We have B, C, and D. So we'll get another swing at this. And then also, since this is recorded, you can always go back and rewind this and watch it over again. Okay, so B. Okay, class, I decided to start back over with 7B because I made a error that would have taken a long time for us to change. So I just decided to start fresh. Okay, so now, if you look here, this would be log x to the third, and that x to the third would be taken to the 1/4 power, minus this would be log z to the 5th, and that will be taken to the 1/4 power. Okay, so now this will be log, we could do the 4th root of x to the 3rd minus log the 4th root of z to the 5th. Now we could change this. We will have log, they have the same base. Since it's subtraction, we will have log of the 4th root of x to the 3rd all over the 4th root of z to the 5th. Now, we could rewrite this as both of these have the same radical and same index. This would be log the 4th root of x to the 3rd over z to the 5th. And that will be your final answer. Okay, now we move on to C. Now C, we have 2 natural log 10 minus 3 natural log 5 plus 4 natural log z. Okay, so now what we're going to do is rewrite this because we want to make this into one logarithm. So this would be the natural log of 10 squared minus the natural log of 5 cubed plus the natural log of z to the 4th power. So this will give us the natural log of 100 minus the natural log of 125 plus the natural log of z to the 4th power. All right. So our next step. Now, we have all of them have the same base. And we have a subtraction sign here. So that means we're going to have some division. And then we also have an addition sign here, which means we're going to have multiplication. So this is going to be a natural log of 100 over 125. But then the z to the 4th will be in the numerator here. Okay, now, the 100 over 125, they both had 25 in common. So that would give us 4/5 or 4z to the 4th over 5. So that would be your final answer. All right, now, We move on here to D. Now D is a little lengthy. We have log base 5 of x plus 2 plus log base 5 of x plus 1 minus 2 log base 5 of x plus 3. Now we have all the same bases. So there's no exponents on the outside. So this is what we would do first. These two are multiplied. So it'd be log base 5 of x plus 2 times x plus 1 because they're added. So they'll be multiplied. And then here, I guess I spoke a little too soon. With this minus 2, we know this 2 will have to go as the exponent for the x plus 3 in parentheses. So now we will have log base 5, and we could do this. This would be x plus 2 times x plus 1 all over x plus 3 squared. Now, since we all know how to do the distributive property, or as some of you all call it, FOIL, first I'm going to expand this, and then we could do the multiplication. This x plus 3 squared is really x plus 3, oh, it's supposed to be log base 5, x plus 3 times x plus 3. Okay, so now we have log base 5. Now we would do our fraction here. This would give us x squared plus 3x plus 2 all over x squared plus 6x plus 9. And that will be your final answer. There's nothing more you could do with that. So that concludes problem number 7. Now we're going to go to problem number 9. All right. And problem number 9 is on the next page. All right, so with problem number 9, they want us to do what is called the change of base formula. It says use the change of base formula and your calculator to determine a decimal approximation of each of the following to the nearest 10,000th. Now, the change of base formula was a very important formula when you do not have a calculator and you're dealing with logarithms. Okay, so since you do have a calculator, it's good. You can check your answer to make sure that your change of base is actually correct. So with that being said, let's go through this. And instead of me going, well, let me find the definition so you all could see the definition as well, because I'm not sure if the definition is helpful to you, but it's on page 366. Let me go back here. You look on page 366. Here's the definition of the change of base formula. So what I'm going to do, I'm going to write out what number 9A is, and then I'm going to compare it with the formula you see. Is log base 7 of 5. Okay, so now with that change of base formula, it's telling you here, if we look here, we have log base b of x. The top value, now this a, this change of base, typically when you change the base, typically the base is going to be 10. So that a, well, they say a is greater than 0. Sometimes it'll be something different, but typically people just rest with base 10. So when you see this a here is representing whatever your new base is going to be. Typically your base is not going to remain the base that you had here. So we have log the new base in x. You notice here that what goes in the numerator is the value here. and then the base that's at the bottom here will go in your denominator. So taking that knowledge, we will have log 5, and we know that's a base of 10, all over log 7. Now, using our Desmos calculator. Okay, so just to check it, if we do log 5, let me close this parenthesis, divided by log 7, we're saying that this change of base is equal to the original problem. So we'll go here and we'll go to log, our base here would be 7, and the number here would be 5. And if you notice here, these answers are exactly the same. So I'm not sure if they want, yeah, they do want us to give a numerical answer here. So we're round to 4 decimal places. So this would be our final answer. It's actually an approximation. Okay, now we go to 9B. This is page 369. Okay, 9B. We have log 6 of the square root of 15. So we have log 6 square root of 15. This could be log square root of 15 over log 6. All right. So we could try that again. Matter of fact, this is what I want to do. I want to write all of these out, and then we could just do the Desmos calculator. It'd be log 47 over log 13. And then finally D, let me see, we have log base 5 of the cube root of 31. Oh, okay, that's a cute one. All right. So this would be log cube root of 31 all over log 5. All right. So now we're going to go to our Desmos calculator. And as a matter of fact, I could shrink it because we don't need the graph per se. All right, so we have log, we'll just do the converted one. We have log square root of 15. Close that parenthesis. Let me move that out here. Okay, then we'll do divided by. And then we have log 6. So that'll give us, rounded to 4 decimal places, that'll give us approximately 0.7557. Now, we go on to the next problem here. We have log 47. We can close our parenthesis, divided by log 13, and then close our parenthesis, and we will have the approximation of 1.5011, rounded to 4 decimal places. Now we go to the last one. We go to the last one. We have log. Then we need the cube root of 31. So we're going to have to click here. Wait a minute, let me go into functions. Yeah, we're going to have to do this nth root. So that'll be the cube root of, what was that, 31. Close that parenthesis. Divided by log 5. So that'll give us approximately 0.7112. All right, so now We have all 4 answers. So let's check them with the original problems. So we already checked 9a. So let's go to 9b. Go to our function here. We will go log. We will type in the base. The base is 6. The number here we had was 47. No, it was square root 15. So we would need a square root and 15. And it gives us the exact same answer when we round to 4 decimal places. Now we go to the next. We'll go log with that base of 13. And then 47 goes inside here and gives us 1.5011 rounded to 4 decimal places. Then last but not least, we go log, the base is 5. And then we want the cube root of, so we'll go to the function. We add a cube root of 31. And it gives us the same answer. So it proves that we did it correctly. So that is basically it for this lesson. So if you all have any questions, please feel free to contact me, and I will see you all later. Have a wonderful day.